Okay, so we just had our learning target video. I explained a little bit about where we're heading with this. So we're going to apply that in just a minute. But first, let's put in a couple definitions. The question is, what is the period of the graph of f of x equals sine of x? Well, what's a period, right? So first, I want us to define what a periodic function is. So our periodic function is a function for which the outputs repeat after a constant interval of inputs. You're basically going to see like a pattern in the graph. You're going to see it just repeats over and over and over again. So a period, that's what they're asking us right here. A period is the length of one cycle of the curve before it starts repeating. So what are we talking about? What does a what does a periodic function look like? What is a curve? All this good stuff. So we are going to fill in this table of values, and this is what I talked about in the learning target video. This x is representing angle measures within a coordinate plane, and we're going to fill in the f of x, which in this case, f of x is the sine function. So what is the sine of a 0-degree angle? What is the sine of a pi over 6? What is sine of pi over 4? What is sine of pi over 3? These are those terminal points from your angles going around the unit circle. So we're just going to fill this in. We certainly can talk in more detail about where these are coming from, but again, we saw some of that in the last video. Your sine of 0 degrees is 0. I'm just going to fill in some basic ones first. Sine of pi is 1. No, it's not. Sine of pi is 0. I meant to say sine of pi over 2 is 1. Sine of 2 pi is 0. Then we can fill in some other ones. Pi over 6 is going to be 1/2. Pi over 4 is root 2 over 2. Pi over 3 is root 3 over 2. So you guys are probably recognizing these are those side lengths of the triangles we've seen in the unit circle. And those are from the ordered pairs on the unit circle. These are all the y values, the y coordinates, because those are the sine function. 2 pi over 3 is a root 3 over 2. After we get past an angle of pi, now we're getting, if you think about in a coordinate plane, now we're down here. Those y values are negative, so we're going to have some negative sine values down there. So we're going to have at 5 pi over 4, we have a negative root 2 over 2. At 3 pi over 2, we have a negative 1. At 11 pi over 6, we have a negative 1/2. 2 pi, we're at 0, so we've gone one full cycle around the circle with our angles from 0 all the way to 2 pi. And then we'll just fill in a couple more. 13 pi over 6 has a sine value of 1/2, and 9 pi over 4 has a root 2 over 2. So let's plot some important points here. We are going to have our x-axis be the angle measures. So I'll just count by pi's to start. So here's pi, here's 2 pi, here's 3 pi. I guess we didn't get all the way up to 3 pi, did we? All right, then our function values, so the y values, the highest value that we get is a 1, and the lowest value that we get is a negative 1. So our function is going to have the highest point at a 1, the lowest point at a negative 1. And then if we just plot these points, we'll plot the obvious ones first. We've got 0, 0. Actually, no, we need a couple more things. So we've got pi. If I go halfway between 0 and pi, that's a pi over 2. If I go halfway between pi and 2 pi, that is a pi over 2, another pi over 2, another pi over 2. So that's where your 3 pi over 2 is. If I go halfway between 2 pi and 3 pi, there's another pi over 2. So pi over 2, 1, 2, 3, 4, we're at 5 pi over 2. And then we'll call that good for now. So if we plot some of these points, we've got 0, 0. Let's see, at pi over 2, we have a positive 1. So I plotted that point, pi over 2, we're at a positive 1. At pi, we have 0. At 3 pi over 2, we're at a negative 1. At 2 pi, we're at 0. And what we notice is we are getting a graph that looks like this. So this is the period. This is going to start repeating after this. So the period is the length of one cycle of the curve before it starts repeating. So this is one cycle of a sine function. And the period for this example would be 2 pi. These other points that I didn't plot specifically are along this curve somewhere. And then we could keep going. What I notice is that we have x-intercepts at 0, pi, 2 pi. We would have another one here at 3 pi. And because this is a periodic function, this pattern is going to repeat. So what I notice is halfway between 0 and pi, we reach our maximum of 1 up here. So halfway between 2 pi and 3 pi, we're going to hit that same maximum of 1 up there. And I know this is just going to continue that pattern. So this is what a sine curve looks like. And it would just continue. You know, it would just keep going with that same pattern. All right, so let's take a look at some key features of the graph of, that should say f of x. There we go, equals sine of x. So we have this thing called a midline. A midline is a horizontal line halfway between the maximum and minimum points on the graph. So this is a sine curve. The sine curve will go through the origin. It has the y-intercept at the origin. Here's the maximum, here's the minimum. If you cut that in half, you've got your midline going right through the center of it. The amplitude is going to be the distance from the midline to the minimum or maximum. So here's our midline. So it's that vertical distance. How many units up? This is 1 unit to the maximum. It's 1 unit to the minimum, so the amplitude would be 1. Because it is a distance measurement, that does mean that it will be the absolute value of, well, I'll just tell you right now. Your amplitude is going to be an a value in our function, and it will be the absolute value of a. All right, so let's wrap this video up. We've got just a couple more key features to discuss. The domain of these functions, sine or cosine, it will continue forever in both directions. You can input negative angles, positive angles, 0. So your domain is going to go from negative infinity to infinity. Your range, it really depends on what the amplitude is. What is the maximum? What is the minimum? In this example, the minimum, your graph goes down to a -1 and it goes all the way up to a +1, and we do include those. So the range is from -1 to 1. Now we know this thing called a midline. So the midline is the equation y equals 0. And then the amplitude for this graph is 1. Something just to take note about the midline. This only changes if there is a vertical translation. So if you're not going to translate, like shift the whole graph up or down, that amplitude stays right there at y equals 0.